Hi there, class. In this video, we're going to be looking at Unit 8, Applications of Integration. This is the first video in our video series for Unit 8. And specifically, what we're going to do is we're going to tackle the first section that I've identified from this unit, which is going to be average value of a function. And so what does average value mean? Well, essentially what we want to do is we want to figure out what the average value of a function given two endpoints is along those endpoints. So like superficially you might say, oh, this is going to be nice and easy. All I need to do is to figure out what f of 1 is, f of 2 is, f of 3 is, f of 4 is, etc. And then divide it by, for instance, if you were going from 0 to 8, divide it by 8. However, there's a little bit more nuance to this problem because we're not dealing with some finite set of numbers here. We're dealing with a continuous function. And part of the definition of a continuous function is that it covers all values between a to b. And so, for instance, if we look at this on a smaller scale from 1 to 2, well, not only is there just f of 1 here and f of 2 here, well, there'd also be f of 1.5 and f of 1.25 and so on and so forth. So not only do we have all rational numbers, we also have irrational numbers. So for instance, between 1 and 2, there's also f of square root 2, f of square root 3. And all of a sudden, our heads start to kind of get a little bit, we start getting a headache, and we've got this realization that, oh my goodness, I'm not dealing with just some set of numbers I can add up. I've got an infinite number of numbers that I need to add up. And don't worry, because hopefully you guys remember that we've got this handy tool in our belts now that we can bust out whenever we're dealing with infinite sums and infinite amounts of something, and that's integration. So we're going to integrate, we're going to figure out what the sum of all those numbers is between a and b, and then what we need to do, because we're talking about an average value, is then divide them by what the difference between a and b is. Now, some of you might be wondering, okay, where exactly this formula is coming from? Like, why does this work? Well, to show the why, we can just give some context to the problem and then remind ourselves of physics 11 here. So because of this function here. So we're given some function that describes velocity, and we're asked to see what the average velocity is. Now, if we think back to physics 11, in order to get an average velocity, well, all you need is a displacement function. And if I'm wondering what the average velocity is between 4 and 9, well, I don't care what happens between 4 and 9 seconds when I'm talking about my displacement and talking about average velocity. Velocity is a vector, displacement is a vector. I just want to know what my change in position is from 4 to 9 seconds. So all I would do in this case right here is I would take d of 9, subtract it from d of 4, and then divide it by 9 minus 4, oopsie daisies, which gives us the 5. So that's essentially what we're doing. And so if I have a v of t function, I've got to get to d of t, which, you know, a couple months ago might have been an impossible task, but now we know that's just a simple case of integration. So what I'm going to do is I'm going to come down here. I'm just going to walk through the first parts of this question to you. I'm not going to get into the plugging in of numbers or anything because we've already done lots of that. But essentially what I'm going to do is I'm just going to follow the formula here. So I know I'm going from 9 to 4 seconds, and I want to integrate from 4 till 9. So I want to sum that infinite series up. And that infinite series goes from, so t squared minus root t, and I want to integrate with respect to t. And I'm going to come down here, and I'm just going to take the integral of this. So this will be 1 over 5 brackets t cubed over 3 minus t to the 3 over 2. I don't see a 3 over 2 over here, which must mean I have the reciprocal as a coefficient. I don't do the plus c because I'm dealing with a definite integral, and I am doing this from 4 till 9. So at this point, this was an FRQ, and you'd have to calculate it out. Then you would plug 9 in, get a number, plug 4 in, get a number, take the difference, and then multiply by 1/5. So I'll skip all that tedious work here. By all means, try it on your own in the paper in front of you. But some quick math tells us that we're going to get 209. And remember, in the context of this question, this 209 is the area under the curve. So this tells us we've traveled 209 meters, or 209, whatever the unit is, in that time frame. And we just don't want to know what our total area is. We actually want to know what the average value is, what the average change of that area is over over the time. So I'm going to take that 209 and divide it by 5, or times it by 1/5, because it took me 5 seconds to cover 209 meters. And so when I do that, you're going to get 41.8. And then the context of this problem is 41.8 meters per second, which is our average velocity over those 5 seconds from 4 seconds to 9 seconds. Now, I'm just going to pop off another example here. I would encourage you to just pause the video, try it yourself, check with a calculator if you want, and then if you don't get the answer, come and watch this video and see where we go. So I'm going to figure out the average value from negative pi over 4 to pi, given g of x is equal to sine x minus cosine 2x. So I'm going to go 1 minus pi minus pi over 4, and I'm going to integrate from negative pi over 4 to pi, and then sine x minus cos 2x, and I'm integrating, with respect to x. Brackets around this for good notation. Then I'm going to have, so this will be 1 over, this is a minus a negative, so this will be 5 pi over 4, but then this can be simplified to 4 over 5 pi. And then this is going to become, so the integral of sine is cos. I don't see a negative on that sign, so this must be a negative, minus, this must have been a sine 2x. Because I don't see a 2 out front here, that must mean there must be a division by 2 here to cancel out that when we do our chain rule through. And I'm going to integrate from negative pi over 4 to pi. And again, at this point, all we're doing is plugging in numbers. You want to be careful here with your signs and all that and evaluating it. But if I follow through with my calculator here, so actually let's do this by hand. Why not? We've got the time. Some of you might be wondering, geez Louise, where did I mess up? So I'm going to plug in negative. So cos of pi is going to be -1, or in this case a 1 because negative of a negative, and then minus. So sine 2 pi is going to be 0, so that's nice and easy. Minus, and I'm going to do a hard bracket around here to remember to take the difference, or to distribute that negative. So pi over 4 evaluates to 1 over root 2. Cosine is so if I follow my cast rule here, so cosine is going to be positive in that quadrant, so I'm going to get a positive 1 over root 2 minus sine 2 pi over 4, which is going to give me pi over 2, but it's negative, so negative pi over 2 is here, so that's going to be a -1, so minus a -1 over 2. Then close this, close that, and then I mean on an FRQ you could leave it like this. It's not gonna be a pretty number when you simplify it down, but I would put this into your calculator and make sure that this evaluates to the same number as we were getting. So I actually don't have my calculator beside me here, so if there is an error, please shoot me an email and let me know. If you're having trouble, by all means shoot me an email, or if we're back in class, come into class and find me. If not, I will see you guys in the next video series, or the next video.